Hello everyone, I am Mukund Ramprasad Soni. I am student of Arihant College of Education under Savitribai Phule University, Pune. The content in this video is on Maharashtra Board, that is SSC Maharashtra Board of grade 9th, subject Mathematics, Unit 2nd Real Numbers, Subunit Surds. Instructions given below you may find useful while watching this video. During this video, several questions will be asked. You can pause the video to answer each question, and you can resume it once you are sure with your answer or to check your correct answer. Also keep your textbook and notebook with yourself so that you can note down the notes, the question answers, and also you can practice during watching this video. Following these instructions will enhance your experience of watching this video and will definitely help you to increase your understanding in the topic which is getting delivered through this video. So students, you must know about prime factorization of the surds, how to simplify the surds, addition and subtraction of a normal rational numbers, like terms and unlike terms, basics of algebraic equation and operations on it. If you know this all before you watch this video, the content in this video will be easy to you to understand and follow. So students, let's recall few things from your previous grade. Like this one, give the simplest form to cube root of 15625. You can pause the video to find the answer, and you can resume the video to check your answer. The answer is 25. I hope you have get it. If not, then try once again or watch the previous video on it. 4x, 7x and negative 3x are they are like terms or unlike terms, and the correct answer is these are like terms because they are having same variable with each. That's why they are like terms. Add 7x, 4x and negative 3x. You must need to know how do you add like terms. You just add and subtract coefficients of them. Then your answer is, yes, do you get it already? 8x, correct. What are you going to learn today? Today you are going to learn like and unlike surds and how to find them. We are going to do operation on surds such as addition and subtraction. So let's learn today and together operations on a surd. So students, let's begin with classifying surds. We are going to classify surds into like surds and unlike surds. Students, you know that we use this right side margin for doing our rough calculation. Do not perform your rough calculation at the back of page. It is not a good habit, and even though your rough calculation won't be examined if you do so. So in order to get right marks to whatever question answers you solve, you must do your rough work along with your fair work on the same page. Do not forget it. So let's begin with how to do classification. I hope all of you can recall the classification of the surds classification of the terms that you did in a previous grade. First, let's have an example on it, like this one. So if I give you two examples, first one is 7x, 12x, and second one is 3x, negative 5y. Now which of the pair is like pair of the terms and which one is unlike pair? Think. Believe in your eyes. They will be able to identify it. As you can see in the picture, in the example itself, when alphabets are equal, that is variables are equal or same or alike or similar, then such pairs are called as like terms. But whereas on other hand, if they are having different one, then it goes unlike terms. In our life is also it happens like we like few things, we don't like few things. But even if there are many things we like or we don't like, we should be able to cope up with both the things because those are equally important in your life. That give you the thrill in a life, that gives you a different change and motivation in your life. Now, in a very similar way, we are going to think for the surds as well. Let's chase an example. Observe this example carefully. Now here goes first example. 8 root 3 or say 5, 8 root 5, negative 7 root 5. Take and second example. 13 root 5, 4 root 13. Now, can you find the answer? Which pair will be called as like pair of the surds and which will be called as unlike pair of the surds? Yes, you may have found it by the time now. Then, as you can see here, as we are discussing about the surds, so we shall compare the surds only from the first term with the second term. If surds in both the terms are same, then you can simply call them like Surds, or else you will call them unlike surds. Isn't it easy? You just have to compare between the surds. When you compare between the surds, you can easily find your answer. Even if the numbers outside of the surds do not match, but when the order of the surd and the radicand of the surds matches with other one, then those are called like. If it does not match, then they are unlike. Let's examine few more examples. So, let's draw a table here. In table, I am going to put 2 examples every time, and there will be just 2 things you have to do. Either give it right or wrong. So, here I am going to put titles. We are following few examples. Comparing lots of examples is the way of scientific thinking, and that is the true way of understanding concept, and it is the same way we are performing right now. Let's have an examples. Let's begin with the first example. First example says that 7 root 3 comma root 3. I hope you have made your choice, and it is like surds. Reason is very simple. These surds are equal by their order and also by their radicand. Let's have another example. Say cube root of 8 and cube root of 4. Now, to justify your answer, first you should simplify it. How you are going to do this? By prime factorization. You take 8, use the rough margin we have produced earlier, then 2s are 4, 2s are 2 and 2 1s are. So here we can simply say, as 8 have 3 same factors, which is 2, 2, 2, and we are having an order as a 3, so that simply gives an idea that answer is 2 for the cube root of 8. But when you think of the factors of 4, which is already available here, see, you don't need to redo it. That is only 2 times 2. But radicand is of 3. Even if their orders are same, but after or before making the factors, the radicands are different, so it becomes an example of unlike surds. Radicands are different, whereas order is same. So it is not just order should be same, the radicand also should be same. Now let's have another example. square root of 100 and negative cube root of 15. This is another example of, again, unlike. And why is that so? Simple reason. Their orders are not matching, isn't it? Even though their radicands are also not matching, so it becomes unlike. Take another example. Fifth root of 7, comma 4 times fifth root of 7. Now in both of these example, what is going on is that their radicand and the order both are same. The order is same. The radicand is also same. Hence, these are like surds. Let's have one more example. Cube root of 625 and again cube root of 3. What was it again? One, 5, 6, 2, 5. These are the two examples which we are going to do. So even if their orders are matching, you have to think what is going it to be, like or unlike. You can't find this answer without factorizing it. So I will leave this question up to you to find the answer. Now let's have few examples from practice set. Let's have sums from practice set 2.3. We are going to solve question number 3. In that, we are going to solve sub question number 1. So, in a first sub question, write the given things first. Root 52, comma 5 root 13. Now observe it. Do you feel that these are the like surds or these are the unlike surds? Do not always go on your vision. Sometimes think little critically. Even if this number 52 on surface looks like not matching with a 13, but we can give simplest form to the 52. You can do the simplest form to the 52 by prime factorization method. Do it in a rough column. So I can directly give it divisibility by 4, and as we know 13 fours are, and 13 is a prime number, so 13 ones are 13, and hence the square root of 4 will be my number outside the root. So root 52 can be rewritten as 2 root 13, as 4 have a square root 2 and 13 is not getting square rooted. So root 52 is as same as of 2 root 13. Now compare this with 5 root 13. See, that's how critical thinking helps you. Do not just go with the numbers which you observe on the surface. Think inside it, what that number can turn into. Think about it and then decide your answer. So yes, these are like surds. Let's have one more example from the same question and sub question second. That is under root 68 and 5 root 3. Now you all know from the critical thinking we did in a previous example that it is not always what it looks on the surface. Sometimes we have to go deep inside it. So let's begin with factorizing 68. I can start with a 2. You can start with 2 or some other number. It's all up to you. Then again with a 2, it brings 17. But 17 is not factorizable because it's a prime number. Now square root of 68 can be written as square root of 2 times 17, and that is equals to 2 root 17. As we have learnt earlier, if there is a no number in the root, then we always consider it. Yes students, what is it? What you consider it? 2. Yes, correct answer. And that's why the radicands which are in the group of 2's, like these 2 appearing 2 times, so I can take 1 2 outside, I will keep the 17 behind. And now as root 68 is at same as of 2 root 17, then we shall compare these 2 numbers, these 2 surds. Even if the order of the surd is same but not the radicand, so they are unlike surds. Finding like and unlike surd is very important skill for us for doing upcoming problems. Now next one is the fourth example, that is 19 root 12 comma 6 root 3. This time I will keep simplification up to you. I will show you the results of the simplification only. So that will be 9 times 2 in the root of 3, as 12 have a factor 4 into 3, and square root of 4 is 2, that's why 2 is outside. That's how the 12 turn into 2 root 3. You can go by prime factorization, that's we did earlier. Same way you will do here. Then it becomes 38 root 3 and 6 root 3, as the radicand and the surds both are matching, that is order of the surd and radicand, then hence it is called as like surds. So keep in mind, dear students, always remember this. In the simplest form of surds, if order and radicand are same, then the surds are similar or like surds. I hope you have understood this through plenty of examples. Now let's do some operations on surds. Today we are going to perform only simple operations such as addition and subtraction. So let's add and subtract surds. Operation on surds. In that we are going to do addition and subtraction. So let's look at an example first. I am taking some different kind of example here at the initial. Say here is a 7x plus 3x is given to us, and another one is 4x minus 2y given to us. Which of the following subtraction is possible and which one is not? Or addition? Yes, correct. If you recall from your previous grade, then you will understand it. And if they are having a like terms, then and then algebraic operations such as addition or subtraction is possible. But if they do not have, then it will not happen anything. It will remain as it is. So the answer for this question mark will be, it will remain as it is, as 4x minus 2y. That means no operation is possible as they are not having like terms. In the very same way, my dear students, in the very same way, you should think about the surd. When you have a surd, and if they are like surd, then there is a possibility of addition and subtraction. Else, it won't do either addition or subtraction. Like this example, 5 root 2 and 7 root 2. So tell me, students, are they like or not? Correct. They are like surds because their radicand and the order both are same. Then in a next step, you will write the numbers other than the radicand along with operation in a bracket, and you will take radicand common, oh my mistake, surd common entirely. So we only take those things common which are same, like this case root 2, and then simply add 5 plus 7, and answer is it 13? No. Sometimes we do make mistakes. We are human. But not revising your mistake and adapting to the mistake so that it won't happen again. will help you to stand back in all the situation. In exam, by mistakenly if you do such kind of thing, then do little artistic, become little artistic and turn it into the number you want. That's how you can overcome your mistakes. I understood. Let's have one more example. Here 3 root 9 or say 12 and 5 root 27. Are they like Surds? Good answer, dears. Unless and until we simplify it, we cannot be sure. So let's simplify this. 3 into the factors of 12 and its retransformation, that is simply after simplification you get answer as a 2 root 3. The steps for simplification, you can do it in a mind or either you can show. Both are valid. In the same way, 5 times 3 times root 3. Now, as the operation, we will be having addition again. So 3 2s are 6 root 3 plus 5 3s are 15 root 3. Then what will be the next step? Taking Surds common and keeping the rest inside the bracket like this way. Then add the things and give a box to your final answer. Let's have one more example. So root hundred minus or say cube root of 100 minus cube root of 1 lakh. Oh, it's very fearsome number, 1 lakh, isn't it? But I know that you won't get worried about it. The simplest approach is factorizing it. And when you have number with multiple zeros, then start factorization with 10 itself. 10. Then you will get answer as 10,000. Again by 10 will give you answer 1000. Again by 10 will give you answer 100. Again by 10 will give you answer 10 and last will be the 1. Now as the order is 3, out of the group of these 3 tens I will use 1 10. Remaining 2 10, that is 10 into 10 100 will remain inside the cube root. To begin with my answer, I keep this cube root of 100 as it is, even though 1 lakh as well, and then I will put the simplified form of it. Then it will become 10 times cube root of 1 lakh. Is it correct? No. Then it will be cube root of 100 minus 10 times cube root of 100. Now they become like surds. Then 1 minus 10. Keep in mind, student, if there is nothing outside here, then keep 1, and hence the cube root of 100 is common. Answer is negative 9 times cube root of 100. Last example. 5 root 7 plus 4 root 3 minus 3 root 2. Can you find the answer? So the answer will be no simplification. Possible. Reason? Unlike, as we have received unlike surds. Understood, students? So let's have question from practice set. We are solving practice set. I am writing it in a short as a PS. We are solving practice set 2.3, and we are going to have now question number 6. In question number 6 it says that simplify, and here we go, say with second example. Do not forget to write question and sub questions properly. Now in a second question, rewrite the question first with equal to sign before writing it. It says 9 root 5 minus 4 root 5 plus root of 125. You may find these two surds are equal. What about this? Now by this time you have already understood we must factorize if number is factorizable. Let's factorize it with a 5, as the test of a 5, divisibility test of 5 is easily applicable on it. And see, it worked very well. If you know the tables, this type of calculation works very faster and smoothly. Now as we are performing square root, so out of given 3 factors, the 2 factors which are same, we can choose it to take common or to take outside the root. Then it will be rewritten as plus 5 root 5. Now take the surd common. So inside bracket you will get 9 minus 4 plus 5, and root 5 in a common will be outside. Now answer is 10 root 5. So even if there are multiple numbers, but when you go with a patience, you can easily find the answer. Let's have one more example. Fourth example from the very same question. That start with a equal to sign always. Root 7 subtracted by 3 by 5 times root 7 plus 2 root 7. Now all of them are like surds. So take the surd common. Now, can you tell what should I write in the place of this root 7 over here? Should I put 0 or 1? Can you recall from my previous example? Correct. It goes with 1. Then you keep 3 by 5 as it is and plus 2. Do you see the things which are outside of the surd? That is only we are keeping inside the bracket. The surd only we are keeping outside. So this 2, this negative 3 by 5 and this one only inside the bracket. Surd only goes outside of the bracket. And that common part can be taken only from the like surds. Now, I hope you know how to solve the rational numbers using a cross multiplication method, or you can use LCM method. I am going with LCM method. Divided by 5 minus 3 by 5 plus 2 times 5 upon 5 root 7, which is equals to 5 minus 3 plus 10 whole divided by 5 times root 7. Hence, the final answer is 12 over 5 times root 7. Give a box to the final answer. I hope you have understood it well. Now students, there are few more things you should keep in mind. Let's take some example. Say we have an example in which we are saying the root of 9 plus 16, and we are comparing it with if we have individual roots like root of 9 and addition with root of 16. So you may think, oh sir, this is just split over here. Root is just taken separately for this, and here the root is taken common. But what happens to it? Are they go equal? Are they go equal or not? Let's try finding the answer of this question. For that, I will solve the LHS first. As you can see, 9 and 16 addable over here because they are inside the one single root. Only one single root. They are not having a separate roots like this. As here you are having one single root, you should add 9 with a 16 directly. That is a 25. And the square root of 25 is a 5. But when you observe here, you don't have a common root. The roots are individual. So you must solve the root first. Unlike of this one. In this we added first because root was common. But here root is different. So I will solve the root first. Then it will become 3 and square root of 16 will become 4. Keep this in a mind. Unless and until you have a separate roots, till then you cannot do this way. And 3 plus 4 will become 7. Now as you can see, 5 and 7 are not equal. So that means root of 9 plus 16 cannot be written as root 9 plus root 16 because they surely do not have same value. So do not just split like this. Not with just 9 and 16, but with any other number. It is a common belief and common mistake happen. Now, this is for you. Think on this. Does the root of 100 plus 36 is equals to root of 100 plus root of 36? I will leave this question to you. You may find the answer for this question. So students, you have learned lots of things today. So let's revise. What have you learned today? Today you have learned about how to find like and unlike surds, and by knowing the like and unlike surds, how to perform the operation on surds such as addition and subtraction. I hope you have understood the content. So let's do little practice. This time you will do by yourself and you will give the answer for these following questions. Master yourself through this practice sums. You can master any content by yourself when you do practices. So using following sums, if you do practices, your concept understanding will get better. Answer whether it's a true or false. Cube root of 81 and cube root of 324 are like surd. Are they? How will you find? And what will be the answer? Next question, add root 5 and 3 root 5 and 5 root 5. What concept you need to know and how will you do? Think. Then simplify root 7 minus 7 root 28 plus 3 root 7. These all questions are provided in a Google form link given in a video description. Do not forget to click on a link and submit your answers. Now, once you get master, once you are aware of your concepts, then you should challenge yourself to give the answers. To make mastery and increase your confidence in a subject. True or false? You have to answer for the coming question as whether it is a true or false. Under root 4 plus 36 is equals to under root 4 plus under root 36. Is it true? Think. You will need to think critically on this. Then simplify. Negative root 40 plus under root of 125 plus under root of 605. All these questions are also available in Google form link given in a description of this video. Do not forget to click on link and submit your answers. Your homework is solving the sums which are not solved in the video from the practice set 2.3. These questions and its list I am going to mention here as well as in a Google form. Solve these all questions and submit those questions and the answers to your teacher. From practice set 2.3, question number 3, sub question 3, 5 and 6. From question number 6, first and third. And that's all, dear students. Thank you for watching video. See you again in the next video. Till then, bye.